Hey guys, today we will be looking at navigation and pathfinding in Unity so we can learn how to automatically move characters or objects towards targets like in this example. Instead of creating code to generate nodes and use algorithms to find the best path, whilst also needing to consider environmental or situational factors, we can happily use Unity's inbuilt navigation system that saves you a lot of time and a lot of code. As such, this video will be presented by me, Kevin, and my partner Eldridge to get you started on using and implementing Unity's navigation system. Here we will learn how to create a character that can navigate to a point whilst being able to walk up slopes, jump over holes, drop down from tall platforms, or avoid obstacles. Not only that, we will also cover some scenarios in which the nav mesh can be used. Please note that majority of this information has been adopted from the Unity manual for version 2020.3 regarding pathfinding. So what exactly is the navigation system? Well, it is Unity's own system, also called the nav mesh system, for implementing navigation and pathfinding for a desired character in a more automated way. The navigation system will give the character the intelligence to navigate through the world so decisions such as jumping over a hole to reach a destination quicker are possible. The nav mesh system revolves around four main components. As seen on the Unity manual, the first is the navigation mesh or nav mesh. This is a data structure which determines if a surface is walkable and is partly responsible for allowing one to find a path from one walkable spot to another. The nav mesh is implemented in the game world by being built or baked on the surface of selected geometry or objects. Next is the nav mesh agent component. This will be added to characters to give them the intelligence to navigate while also being considerate of situations such as needing to avoid obstacles. Let's now refer to characters as agents. Now, an off-mesh link is an integral part of the behavior of agents. They are like signposts letting agents know that there is a shortcut. Hence, off-links allow agents to do things like jump over a hole or drop down from cliff or platform, mainly when it is quicker to do so. Lastly, the nav mesh obstacle is as the name suggests. However, it is focused on moving obstacles or those controlled by the physics system. This component tags objects as obstacles that agents should avoid when navigating through the world. For example, if going up a slope is the fastest route, but a box has fallen on the path, the agent must immediately find a new path. Now that we know of the main components, let's quickly understand how the parts of the navigation system works. To begin navigating, the agent needs to know the areas that it can walk on. The navigation system defines this by laying out a nav mesh on top of surfaces of geometry or objects within the game world. A nav mesh defines the areas that an agent can stand or walk on and is also modifiable to suit their body specifications. To be a little bit more specific, nav meshes are a set of connected convex polygons which each store information about its neighbor. With this idea, we can find the path to a target destination. To begin, the start and end locations are mapped to the polygons they inhabit. Then with the start location, visit the neighboring polygons and then their neighbors until the destination polygon is reached. A star is the algorithm that Unity uses to find a path. When following the path, the sequences of polygons between the start and end polygon is known as a corridor. As such, agents will move towards the next visible corner of a corridor. With a single agent, this is fine, but with multiple, it becomes a mess as they are all following the same path but then now have to consider avoiding collisions with each other. So as seen in the Unity manual, steering an agent is done by using the position of the next corner to calculate and use a desired velocity to reach that corner. Desired velocity can lead to collisions with other agents, probably because it doesn't consider other objects getting in the way. The nav mesh system's obstacle avoidance behavior determines a new velocity which considers desired direction and prevention of collisions with other agents and edges of the nav mesh. When the steering and obstacle avoidance behaviors have been considered, the final velocity can be calculated. These are then used to simulate the movement of the agent with the addition of acceleration to help with creating a natural and more smoother movement overall. Now that we have an idea of how the nav mesh system works, let's begin implementing it in Unity. Here we have a basic scene with a floor and walls or shapes scattered around the level. These will form the area that the agent will walk within. To allow the agent to know where it can walk, we need to create a nav mesh from these objects. This process is called baking. First we select the objects, then mark them as navigation static, as seen here. Doing so will include the objects in the baking process. Now that that's done, we need to access the navigation tab by clicking on Window, AI, then Navigation. Then click on the Bake tab. We may need to adjust the nav mesh sizing and placement based on how we want the player to navigate. Agent radius determines how close the agent can get to a wall or edge. Agent height defines the lowest height that the agent can travel to. Max slope is about the limit of steepness that an agent can walk up. Step height defines how high the agent can step. Once adjusted, press Bake and you'll now see blue polygons on the surfaces. These are the nav meshes, and as you can see, the settings have been considered when making it. Let's try changing the agent radius and see the differences. Now that we have defined the walkable area, we just need an agent to navigate through the level. First, create a capsule near the edge of the level. I'll rename this to Agent for readability. Now add the nav mesh agent component on this object. This component deals with the pathfinding and movement of the agent and is the key advantage of using the nav mesh system. Now we just need a script to initiate this behavior. For this script, we are simply going to have the agent move to a target every time we press play, meaning that we will need to first create a target destination. Let's add another capsule on the other side of the level and rename it as destination. Create a new script and give it an appropriate name. Now in the script, add these namespaces so that we can initialize and utilize the navmesh agent behavior. Then add a transform variable called destination to refer to the destination capsule in the level. In the start method, we gain a reference to the agent's navmesh agent component and then assign the destination to the position of the destination capsule. Now back in the inspector of the agent, add the new script and then assign the destination capsule as the destination object. If we then press play, the agent capsule should move towards the destination capsule by following a path that avoids the walls or cubes. Let's now look at adding obstacles to obstruct the agent's path, to which a new path must then be generated in real time using the obstacle avoidance behavior. In this use case, the obstacle will need to be physics controlled so that it can move. Using this scene, we have a black box floating on top of a slope. This has a navmesh obstacle component added to it, as well as a rigid body component. In the obstacle component, its shape is set to box. The shape is sort of like a box collider but for navmesh, allowing its bounds to be known. Then tick the carve option. This cuts a hole under the obstacle so that in real time, as the obstacle moves, the agent will be able to find a new path with the updated navmesh. So far we've been looking at pathfinding within a single level area. What if there were higher or lower level floors that could be traversed upon? Let's see how off-mesh links can be used to provide shortcuts when having multiple platforms in the world. Using the same scene, we will need to manually create off-mesh links between the edge of this box and the floor under it. Doing so will allow the agent to know that there is another path it can take to the destination. Depending on the positioning, it will jump or drop, and in this case it will drop off the box. Regarding the pathfinding, if the path involving the off-mesh links to the destination is quicker, that is the path the agent will then take. As previously mentioned, create two small game objects, shape or not, and name one off-mesh start and one off-mesh end. Place the start at the edge of the box object as shown, and place the other on the floor or the estimated landing spot as shown. Now add an off-mesh link component to the off-mesh start game object. Now assign itself as the start field and assign the off-mesh end as the end field. Given the layout of the map, if I press play, it should use the slope path and the off-mesh links to reach the destination. And yes, it does. Without it, you would see it going around the slope instead, like this. If you have a larger map, this manual process could take up a lot of time. Luckily, navmesh allows you to automatically generate off-mesh links on the navmesh objects. I will use this scene to demonstrate it. Please note that generating off-mesh links will only occur if there's no interference between the start and end points. As you can see here, I will go to the navigation tab and then the object tab and tick generate off-mesh links for both blue platforms. Now in the bake tab, we need to consider two parameters before baking the navmesh. The first is drop height. This essentially specifies how high the agent is able to drop down, meaning that if the platforms were way taller than the height, no off-mesh links would be generated. Next is jump distance, which specifies the longest distance that the agent can jump, or more technically, the longest distance that the off-mesh links can establish a connection with each other. I will be using these numbers as they worked in my last playtest. When I press bake, we can see the numerous off-mesh links that have been generated for us. This can save us a lot of time and effort whilst also generating many more possible paths to the destination. Now when we press play, we can see the agent use the off-mesh links to reach the destination. Let's quickly cover the Areas tab. As you can see on the scene, the nav mesh of each object is color-coded according to the navigation area assigned to it in the Object tab. The navigation area has an associated cost, which is considered when the A-star algorithm is used. Continuing on from this scene, if I were to change the cost of jump to 5, which is 5 times more than the base cost of 1, the agent will not jump to the other platform like before. So even if traversing the platforms may seem quicker, changing the cost can be useful in establishing alternate routes or favorable routes. And that is all I have for you guys regarding the basics of the nav mesh system. Eldridge will now provide a more in-depth look at the nav mesh system using some common scenarios developers may encounter, such as the moving obstacles we lightly covered earlier.
So now you should have a general idea of Unity nav mesh and how to use it. In the rest of the videos, I will show you how you can use the nav mesh in 3 common scenarios in games. First, let's talk about moving obstacle. In most games, the environment is always changing, and AIs must adapt to it to avoid obstacles. For that, you will need a nav mesh obstacle component. So let's take a look at it. The first few attributes of a nav mesh obstacle are very similar with any collider, including the offset and the scale of it. So let's talk about carving. Carving means when you bake, will the nav mesh draw an unwalkable area around the obstacle? So for example, let's check the carve checkbox, and when we bake it, you will see there is an unwalkable area around the obstacle. So let's take a look at it. So if we check the carve checkbox but not checking the carve only stationary checkbox, you can see the carving area is moving with the moving obstacle, so that our agents can build a path around the moving obstacle. As you can see here, the path will be updated when the carve area update. However, it's actually baking and carving the nav mesh whenever the game objects move a certain distance, which can be controlled by move threshold. It is basically baking and carving per 2 or 3 frames, which is very resources consuming. Second is, if we check the carve checkbox also with the carve only stationary checkbox, that means it will only carve the nav mesh whenever the game object is stopped moving for a certain amount of time, which can be controlled by time to stationary. So for example, now the obstacle is moving, so it didn't carve. And if it stops moving, it will carve an area around it. Lastly, if we didn't check the carve checkbox at all, the nav mesh will not update even if the obstacle stops moving, as you can see here. Luckily, the agent will always try to avoid any game objects with a nav mesh obstacle component on it. As you can see here, the agent we'll try to adjust its velocity to avoid the obstacle, but not building a new path around it, just adjusting its velocity. Different from when you're carving the area, it will build a different path from it. So there are 3 different types of nav mesh obstacle that you can choose from, and you can always balance the performance of the hardware and the precisions of the agents to choose the ideal types of nav mesh obstacle. So the second scenario, like let's say you have a floor trap in your game that the AI would walk on it like normal if it's not activated, and if the trap is activated under the AIs, they will stop and maybe damage them or other thingy. And if the AI is if the trap is activated, the AI should avoid the trap automatically. To do this, you will need an object with collider that is triggered is checked, a nav mesh obstacle component, and a script to control the trap. The first thing you need to do is go to the object tag under navigation windows. Make sure it is navigation static and walkable, so that there is a walkable area on this obstacle itself, or else when you enable the nav mesh obstacle, the agents will be teleported outside of the obstacle automatically. Second things you need to do, make sure is carve only stationary, so that when it's enabled, the agents can generate a path around the trap. Third, move the nav mesh obstacle so that it will fall on a surface that the agents can walk on top of it. Fourth, changing the offset of the box collider so that it's on top of the floor instead of like inside the floor. So now we have set up everything in the scene. Let's take a look at the script. As you can see, the first 2 material is just for showing if the trap is activated or not. You should have a reference to the renderer for changing the material. You should have a reference to nav mesh obstacle component so that you can switch it on and off. And you should have a list of nav mesh agents that is standing on top of the trap. First, easy, just get the reference of the components. So now, remember we have a box collider on top of the trap. So whenever a nav mesh agent enters the trap area, it will add the agents into the list. And when it exits, just remove it from the list. So if we press spacebar, we will turn the material of the trap to red and make the nav mesh obstacle component to be enabled, so that the agents outside of the trap will avoid the trap, and then make the NavMesh agent components in each of the agents on top of the trap to be disabled, so that they will stop moving. And then vice versa, when you release it, just do it in reversed, so that now you'll have a trap that when you activate it, agents avoid. When you not activate it, agents rock a course, and activate on top of it, they stop. So usually AI would have to interact with other game objects physically in a game. So let me show you how to cope Unity NavMesh system with the physical system in Unity. So this is mostly script word. Let us look at the script. So first thing, you may want a variable that controllable from the editor, as for the accelerations when it launch, and you should have the reference to the NavMesh agents components and the rigid body components in the script. So first, you may want to enable the NavMesh agents components of the agents when the agent touches the ground, which basically means touching the navigation surface. Second, as for the inputs, these four inputs basically are implemented the same, so we just take one as example. So when you input when the agent should be launched, you should disable the NavMesh agents, because if the NavMesh agent is not disabled, the agent will always stick on the NavMesh surface and will not launch it to the air. So you must disable it before launching to the air. And then just simple Unity physics, like adding velocity to the rigid body so that it launch to the air. And that's it. That's just all script that you need to do for controlling the force applied to an agent, so that when it touches the ground, it just generate a new path to destinations and continue to go there. If launching to the air is not needed, so you're just a mini push instead of launching in the air, you can just use the velocity properties in the NavMesh agents components, like that. NavMesh agents velocity, and then you can change the velocity of that, so that although it will always stick on the NavMesh surface, but you can push the NavMesh agents around. It may be more, you may able to see it more clearly in the scene view, so that you can see there is a velocity of the agents itself.